Hello students, let's solve the last section of exercise 2.2 of polynomials. So here we have to find the zero of the polynomials. Now in order to find the zeros of polynomials, you have to first equate the polynomial expression on the left hand side to 0, and when you substitute this as 0, for example in the first sum, px is equal to x plus 5. For the value of the zero value of polynomial, the value of px is going to be 0. So I am going to say px is equal to 0, and then I am going to equate 0 to x plus 5. Let's see how we do this with the first example. So your polynomial is px is equal to x plus 5, right? So px is equal to 0, which implies x plus 5 is equal to 0, right? I am going to bring 5 on the right hand side, so x is equal to minus 5. So for the value x is equal to minus 5, px, the polynomial is 0, the value of px is 0, therefore minus 5 is the zero of polynomial. Okay, before I write the answer, let me just quickly verify this for you. Substitute x is equal to 5 in this polynomial expression, you get minus 5 is equal to minus 5 plus 5, which is equal to 0. Therefore, for the value x is equal to minus 5, your polynomial becomes 0. Therefore, minus 5 is the zero of polynomial px is equal to x plus 5, since because p of minus 5 gives me 0, right? Let me solve the second sum for you. So your sum is px is equal to x minus 5. Again, I am going to say px is equal to 0, which implies x minus 5 is equal to 0, right? I am bringing minus 5 on this right hand side, so x becomes 5. Therefore, for the value x is equal to 5, the value of polynomial is 0, which is why 5 is the zero of polynomial px is equal to x minus 5, right? Because p of, let me just write this for you over here, because p of 5 gives me 0. So are we clear? You can even verify this if you want. Let's verify it. Substitute p is equal to 5 in the expression, this expression, p of 5 is equal to 5 minus 5, which is equal to 0, right? So the basic funda is you first you go in the descending order. Earlier, to find the 0, to verify whether the polynomial whether the value is the 0 of the polynomial, we would take the value, substitute in the polynomial, right? And then we would say that px is equal to 0. But now here in verifying whether this is a 0 of the polynomial, you are first going to take the polynomial itself as 0, right? And then you keep solving further until you get the value of x. So initially in the previous section, that is the third section, this is the fourth section that we are referring to, we were already given the value of x, and then we would substitute the value of x in the polynomials. But here in the last section, you have to find the value of the polynomial, you have to find the value of x, okay? Okay, let's proceed with the third sum. Px is equal to 2x plus 5. So I am going to say Px is equal to 0. Now since px is equal to 0, obviously this is going to be equal to 0. So 2x plus 5 is equal to 0, right? Now this is getting multiplied, so you can't really bring 2 over here. First you have to take 5 on the left hand side, so this becomes 2x is equal to minus 5. Why minus 5? Because 5 is positive here. When it shifts to the right hand side, it becomes negative. Now 2 is getting multiplied with x, so it will come here and divide. So minus 5 upon 2, right? So minus 5 upon 2 is a 0 of polynomial px is equal to 2x plus 5, because p of minus 5 upon 2 gives me 0. If you want, you can verify it, but it's not really necessary to verify it in your examination papers. Only if it is asked, you can just substitute x is equal to minus 5 by 2 in this expression, and you will get p of minus 5 upon 2 as 0. Okay? Okay. Let's see the fourth sum. Px is equal to 3x minus 2. I'm going to say px is equal to 0. Therefore, 3x minus 2 is equal to 0, right? Therefore, 3x, I'm bringing 2 on the right hand side, is equal to 2. Minus 2 becomes 2 when it moves to the right hand side. 3 is getting multiplied, so it will come here and divide 2. So x is equal to 2 upon 3. So for the value 2 upon x is equal to 2 upon 3, p of 2 upon 3 is 0. Therefore, your answer x is equal to 2 upon 3 is a 0 of polynomial px is equal to 3x minus 2, because p of 2 upon 3 is equal to 0. Okay? Moving on, fifth sum, px is equal to 3x. Okay? Again, let's say px is equal to 0. Therefore, 3x is equal to 0. X is equal to 0 divided by 3. 0 divided by anything gives me 0. Right? So, for the value x is equal to 0, you get p of 0 as 0. Therefore, x is equal to 0, or 0 is the 0 of polynomial px is equal to 3x, because p of 0 is equal to 0, right? Okay, the sixth sum now. Px is equal to ax and a is not equal to 0. I'll tell you why they have mentioned a is not equal to 0. Okay. First, let's just follow the standard. Px is equal to 0. Therefore, ax is equal to 0. Therefore, x is equal to 0 upon a. Now, 0 divided by anything gives you 0. But 0 divided by, if a would have been 0, this would have been anything, any constant, okay, any constant or variable divide by 0 is not defined. Okay, this is why it is mentioned that a is not equal to 0, because if a would have been equal to 0, then x would have been not defined. Okay, so x is equal to 0. This is just for your understanding. You don't really have to mention it because they've already given as a is not equal to 0. So your x is equal to 0. So for 0 is the 0 of polynomial px is equal to ax, where a is not equal to 0, because p of 0 gives me 0, right? Okay, so now the seventh sum, last sum of exercise 2.2. Px is equal to Cx plus d, where C is not equal to 0. So maybe C is going to divide, which is why they've mentioned that it is not equal to 0. Let's see when we solve. And C and D belong to the set of real numbers. Alright. So I'm going to say Px is equal to 0, right? Therefore Cx plus D is equal to 0. Don't get confused when you get too many letters like these. Just consider D as a constant. For example, you can say that D is 2 and C is a coefficient, it could be 3, right? So you're going to follow the same method of solving. D is positive here. Suppose if it would have been plus 2, you would have taken here and made it minus 2, right? So plus D can, when you take it here, it becomes minus D. Correct? So now C is getting multiplied over here, it will go and divide. See, remember I told you that C might divide, which is why they will mention that it is not equal to 0. Right? So for x is equal to minus d upon c, your polynomial is 0. Therefore, minus d upon c is a 0 of polynomial. Px is equal to Cx plus d, because P of minus d upon c is equal to 0. Now since this is a tricky one, I am going to help you verify it whether minus d upon c actually gives P of minus d upon c as 0. So let's quickly verify, it won't take much time. Verify. Substitute x is equal to minus d upon c in this expression of polynomial. So minus d upon c, I get c, you are going to substitute for x, so minus d upon c plus d, right? C ones are c ones are. Okay, you are left with 1 into minus d gives me minus d plus d, correct? Looks more like an A. Let me make the sticks clear. So minus d plus d is giving me 0. Bang on, you have P of minus d upon c is equal to 0. Hence we have even verified that d minus d upon c is the actual 0 of polynomial, one of the zeros of polynomials of the polynomial Cx plus d, where c is not equal to 0 and c and d belong to the set of real numbers. So with this we wind up exercise 2.2. We will discuss the remaining topics in the forthcoming lectures. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.